Good day, everyone. Today we will be discussing about comparing the sample mean and the population mean in a large sample size. The most essential learning competencies that we will be discussing for today is first, the learners compute for the test statistics value or population mean. The learners draw conclusion about the population mean based on the test statistic value and rejection region. And the third one is the learners solve problems involving test of hypotheses on the population mean. The z-test of one sample mean is used to compare sample mean and population mean. We use the z-score formula for sample means because we are dealing with sample means. Thus, by the central limit theorem, we have z equals x bar minus mu all over sigma sub x bar, where sigma sub x bar is equal to sigma over square root of n. So I know that you are all familiar with this formula because we already discussed this during our third quarter period where we discussed central limit theorem. The z-test is generally used when the population standard deviation is known or given. If the population SD is unknown or not given, the z-test can still be used provided that the sample size is large or n is greater than or equal to 30. Let's start. The first one is a new drug on the market is claimed by its manufacturers to reduce overweight women by 4.55 kg per month with a standard deviation of 0.91 kg. 50 women chosen at random have reported losing an average of 4.05 kg within a month. Does this data support the claim of the manufacturers at 0.05 level of significance? Okay, so let's now have the answer. So we have five steps. First one, we need to identify the null hypothesis, alternative hypothesis, the sample size, sample mean, and population standard deviation. For the second step, we need to find the type of test, alpha or level of significance, and the critical value. And then we need to draw the rejection region, of course. For the third step, we're going to use the formula z is equal to the quantity x bar minus mu, quantity times sigma I times square root of n all over sigma. Okay, and then for letter D, we need to know the decision, if the null hypothesis will be accepted or rejected. And then for the conclusion, we're going to answer the question on the given problem. So let's start. For number one, we're going to start with the parameter. So for for the parameter of the given problem, based on our problem, the new drug on the market is claimed by its manufacturers to reduce overweight women by 4.55 kilogram. Since there is what we call word, which is reduce, it implies less than. So therefore, the parameter is mu less than 4.55. Now, if we're going to transform that parameter into null and alternative hypothesis, we already know that if it is null hypothesis, it is always mu equals 4.55. And for alternative hypothesis, we will just simply copy the parameter. So we have mu less than 4.55. For the sample size, it is written that 50 women is chosen at random. So it implies that our n is equal to 50. For x bar, that is our sample mean. For our sample mean, that is sample mean. For our sample mean, it is reported that the average of 4.05 kilogram. So we have mu, its x bar is equal to, 4.55, 4.05 rather. And then for our population standard deviation, with a standard deviation of 0.91 kilogram. So we have 0.91. So already done with the first step. On the second step, we're going to identify the type of test. We already know that the type of test is one-tailed. Why? Because we're going to take a look on the alternative hypothesis. If the alternative hypothesis shows less than or greater than, automatic it is one-tailed. However, if it is not equal, automatic that is two-tailed. For the alpha value, we have 0.05. Now, if we're going to take a look on our critical value on our t distribution table on the bottom part, we have z. So taking a look on 0.05 one-tailed, we have 1.645. Since we're dealing with less than automatic, our critical value is negative. So let's now show negative 1.645. And then we have the shaded part on the left side. Okay, now let us now find the computed value. So we already have the critical value. Now let's find the computed value. To find the computed value, we're going to apply z is equal to the quantity x bar minus mu times the square root of n all over sigma. Let's do the substitution process. So instead of writing x bar, we're going to write 4.05 minus 4.55 times the square root of n, which is 50, all over your sigma, which is 0.91. Now, by simplifying this, we're going to start subtracting 4.05 by 4.55. Or if you're going to use your scientific calculator, you can do this one. You're going to press double parentheses 4.05 minus 4.55 times square root of 50, and then close parentheses, then it divides 0.91. If you're going to press this using your scientific calculator, then you can get the final answer. So the final answer is negative 3.89. So to know the decision, let's plot the computed value. So if we're going to have negative 3.89, we already know that negative 3.89 will fall here. So we already know that the computed value falls on the rejection region. So thus we can say that the decision is reject H sub O. Now, for the conclusion, since we reject the H sub O, it means that we reject H sub O, the correct is H sub A. So again, I'm going to repeat. Since we reject H sub O, it means that H sub O is not correct. The correct is H sub A. So let's now check the parameter. The parameter is deals on H sub A. So therefore, we can say that the conclusion is the data support the claim of the manufacturers at 0.05 level of significance. Sir, how are you going to know if the data support or not didn't support the claim? If your if the null hypothesis is accepted, it implies that H of O is correct and H of A is not correct. However, as you can see, our parameter deals on H of A. Since it deals on H of A and it's not correct, automatic it did not support the claim. But since our parameter is just the same with or deals on our alternative hypothesis and our alternative hypothesis is correct, it implies that the data support the claim of the manufacturers. Let us now try another example. The production manager of a large company estimates that the mean age of his employees is 22.8 years with a standard deviation of 4.6 years. The treasurer of the firm needs a more accurate employee mean age figure in order to estimate the cost of an annuity benefit program being considered for employees. The treasurer takes a random sample of 70 workers and finds out that the mean age of the employees sampled is 26.2 years. At the 0.01 level of significance, what can the treasurer conclude about the accuracy of the production manager's estimate? Let's start with the parameter. For our parameter, we have mu because the mean age of his employee is 22.8 years. So we have mu equals 22.8. So now if we're going to identify the null and alternative, it will be mu equals 22.8 and mu is not equal to 22.8. Now for the number of sample, it's written that dealing with 70 workers. Now for X bar, we have, it is written that the mean age of the employees sampled is 26.2. And our population standard deviation is with SD of 4.6 years. Okay, now, what is the type of test? Since we're dealing with not equal on our alternative hypothesis, we're dealing with two-tailed. Now, for our alpha, we already know that the level of significance is 0.01. Now, for critical value, we're going to take a look on two-tailed 0.01, and that is 2.5 0.576. But since we're dealing with not equal, automatic, the sign will be positive, negative. So let's now plot negative 2.576 and positive 2.576. And then we have the shaded part here on the left and the right side of the normal curve. Now for our third step, we're going to find the computed value. So let's now have the substitution process. So instead of writing x bar, we're going to write 26.2 minus 22.8 times square root of 70 all over sigma, which is equal to 4.6. Now, by just again pressing on your calculator, double parentheses, 26.2 minus 22.8 times square root of 70, close parentheses, and then divide 4.6, we can have z is equal to 6.18. So we have 6.18. Now, if we're going to take a look on 6.18 on our rejection region or on our normal curve, we can see that 6.18 falls here on the positive, sorry, it's positive. So 6.18 falls here on the rightmost side of the normal curve. And then we can now say that it falls on the rejection region. So therefore, our decision is reject null hypothesis. Now, since we reject null hypothesis, automatic that null hypothesis is not correct and the correct is the alternative hypothesis. However, the parameter deals on the alternative hypothesis, which is mu equals 22.8. And we can see that it is not correct. So therefore, we can say that the production manager's estimate is not correct. Okay, let us now have the third example. A psychologist believes that it will take greater than an hour for certain disturbed children to learn a task. A random sample of 100 of these children results in a mean of 50 minutes to learn the task. Should the psychologist modify her belief at the 0.01 level if the population standard deviation can be assumed to be 15 minutes? Let us now start identifying the parameter. So the parameter in this example is, or in this problem is, a psychologist believe that it will take greater than an hour. So it will become mu is greater than 1 hour. But since we're dealing with minutes, let's now rename this as mu greater than 60 minutes. Why? Because 1 hour is equal to 60 minutes. So if we're going to transform mu greater than 60 minutes into alternative and null, it will be mu equals 60 and mu greater than 60. Now, for the number of sample, we're dealing with 100. This is 100. Now, for x bar, we're dealing with 50 minutes. So, mean of 50 minutes. And then for sigma, or our standard deviation, population SD is equal to 15. So, we're done with first step. On the second step, since we're dealing with greater than on our alternative hypothesis, automatic, our type of test is 1/2. Now, for alpha, we have 0.01. For critical value, we're going to take a look on the bottom part of the t-distribution table, which is Z, and then take a look on 1/2 0.01. We can see that we're dealing with critical value 2.326. Since we're dealing with greater than, automatic that we're going to use positive 2.326. Let us now plot positive 2.326. And then the shaded part is on the rightmost part of the normal curve. Now, on our computed values, we already have the critical value. For the computed value, we're going to start substituting the given value. So we're going to have x bar. So our x bar is 50 minus our mu, or the population mean, which is equal to 60, times the square root of n, or the sample size, which is equal to 100. Now, divided by the sigma, which is equal to 15. So now, in order for us to find this one or easily get the final answer, press on your calculator, double parenthesis 50 minus 60, close, times the square root of 100, close, divided by 15. And we can get the value, which is negative 6.67. So if we're going to take a look, negative 6.67 is on the leftmost part of the normal curve. And as you can see, the shaded part is on the rightmost part. So therefore, the computed value falls on the acceptance region. So therefore, we can say that our decision will be accept the null hypothesis. Now, since we accept the null hypothesis, automatic that this is correct and this is not correct. So null hypothesis is correct. Alternative hypothesis is not correct. However, our parameter deals on the alternative hypothesis. Since it deals on our alternative hypothesis, it implies that is not the parameter is not correct. So therefore, we can say that the conclusion, yes, the psychologist should modify her belief. Why? Because it is asked that should the psychologist modify her belief at the 0.01 level? Yes. Why? Because the psychologist claims is not correct. Because the psychologist claims that it will take greater than an hour for certain disturbed children to learn a task. However, since we accept the null hypothesis, we believe that as a that the mean should be equal to 60 minutes. Okay? So that's all. Thank you and God bless. So please hit the notification bell button so that you're going to be updated with our video tutorials. So that's all. Thank you.